Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the GRI number 189-12. This is actually a -BLK or a BL because this is a black switch, a door position switch is what it would be. Here is what it looks like. Switches like this are two-part switches. There's the there's the part with the leads or the wires, and then there's the other part. One will incorporate a magnet. That is how these work. There's a part that when the two pieces are brought together actually moves in position and changes the state of the switch. The 189-12 is actually a particular type of switch. Every switch is particular, but we're going to talk about the type of particular switch the 189-12 is right now. Just a couple of basic dimensional properties. The diameter of the face of the unit, it's about 1 1/8 or so. This is going to be meant to go into a 1-inch hole. It's basically a snap fit type of situation. The length of the leads, just for the sake of archiving that data, appear to be about 12-inch in length. Now let's talk specifically about what this is and where you'll use it. According to the manufacturer's published data, this 189-12 is what's called an open loop. So a little bit of background of these switches, or types of switches. Terms: single pole, single throw, single pole, double throw, double pole. I suppose you'd have a double pole single throw and a double pole double throw. Open loop, closed loop, etc., etc., etc. Lots of terms. The bottom line is, when you have a switch that has two leads, when the parts are separated, there's either power through the circuit or there's not. When you bring them together, there's either power through the circuit or there's not. So you've got two possible states, on or off. Or is there juice flowing? Is there juice not flowing? Or is the circuit open or closed? Is the bridge up or down? Whatever you want to call it. But when you change the proximity of the two components relative to the first condition, you switch the condition, you switch the state. So this is either wired to be, this is either configured in the state where the parts are not together, as either an open circuit, meaning there's no power that flows through there, or it's closed, meaning there's power will flow through it. So an open loop switch has a normal state. Think of a light switch. What's the normal state of a light switch? Lights are off. It's logical to think that a light switch, the normal position is off, or open, meaning the circuit is open. So the normal condition of this should be that there would be no power in this instance. Okay? That should be what we would consider the normal circumstance. Let's test that really quick. Now, the way you test things like this is really easy. You've got a multimeter. You can simply check for continuity, meaning all that happens is when you put your two probes down onto the wires, the multimeter will send a very, very small amount of voltage through the wires. And if there's a continuous path for the electricity to flow, you'll hear a buzzing sound. That's what this is. So we're going to turn our multimeter on, and I have this set to continuity. This is a really inexpensive multimeter that I obtained by attending a class. And I've got it set to continuity. It's got a little horn there. Now I've got a more expensive multimeter. This is the one I use. So there you go. So I've got it set into continuity. I'm going to separate my pieces. I'm just going to put this down, and I'm going to take my leads and I'm going to put my probes onto the leads and see if we can hear continuity. You can hear that. So I've got the two parts separated, meaning when these two parts are separated, think of the door being open. They're separated. But when I close the door and I bring this part to this, the buzzing stops. Okay, so an open loop, the normal, it's a lot to wrap your head around, and only with time and experience and continuing to expose yourself to the concepts will it start to, for me, make sense. What's the normal position of a door? It could be open or closed, but the purpose of the door is to be closed. That's the normal position. Therefore, the normal state of an open loop is that when the two pieces are brought together, it's an open circuit. The normal state of that is an open circuit. When we had this piece missing from this piece, we had continuity, meaning we could hear the buzzing, meaning power was flowing from this lead up there, through here and down to here, through my multimeter, through the probes, and in the closed path. So the reason that you would use this switch, let's talk about that. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. The reason that you would use this switch would be the door is closed. This is a normally open, or pardon me, stop. It's not normally open. This is an open loop type of switch. That means the normal position of a switch is in the closed or off position, or no power is being coursed through there. So this is normal. The door is meant to be normally closed, meaning the purpose of a door is to close off two areas from each other. The purpose of this switch is, in this instance, we know in this instance there's power. We know in this instance there's no power. We're going to call this door closed, because it would be when this is installed per the instructions and the door is closed, this is what will happen. There will be no power. The purpose, or the reason you would want to use this switch is that when you open the door and separate the two parts, you want power to flow. Meaning, you want something to turn on or something to turn off when the door is opened. For me, the easiest thing to think about is when the door is opened, I'm going to have an indicator at a panel somewhere that makes a light go on. That door's been opened. Or I can have the door open, turn on an annunciator, which is a fancy word for a loud, irritating buzzing sound. You could have anything turn on when the door is open. When you have a open loop switch configuration like this. Now, of course, GRI makes closed loop. It's the reverse of everything we just said. It would be a 184-12, would be a closed loop. Now, what's interesting is we have these terms normally open and normally closed, and that's where it starts to get a bit more intellectually distressing, where it's harder to wrap your head around. An open loop and a normally open are not the same. An open loop circuit is a circuit that does not, and I actually asked Google AI, is an open loop circuit and a normally open switch considered the same? And it responded, no, an open loop circuit and a normally open switch are not considered the same. An open loop circuit is a circuit that does not have a complete path for current to flow. An open loop circuit is a circuit that does not have a complete path for current to flow. An analogy that I said it earlier. The bridge is either up or down. When the bridge is down, you can have traffic flowing through there. But when it's up or the bridge is open, there's no path for electricity. And that's what we're kind of thinking about, tricks to make your mind be able to grab on and grasp the concept. That's how I do it. And that's how I know how others do it as well, people that are considered most expert in the industry. So an open loop circuit is a circuit that does not have a complete path for current to flow. We got that. This can be caused by a break in the wire, a disconnected component, or a switch that is in the open position. So what prevents power from flowing? One of those conditions. A normally open switch is a type of switch that is open when it is in the off position and closed when it is in the on position. Normally open switch is a type of switch that is open when it's in the off position. Okay. When a normally open switch is in the off position, it breaks the circuit and prevents current from flowing. When it is in the on position, it closes the circuit and allows current to flow. So AI goes on to say, in other words, an open loop circuit is a circuit that is always open, while a normally open switch is a switch that is open when it is in the off position. So I take that as meaning this open loop piece of equipment doesn't have an on or an off. It's either open or closed. Whereas a switch, like a light switch, then they use the term normally open or normally closed. It's open. It's an open loop. Pardon me. A normally open switch opens the circuit when that switch is in the off position. So they are indeed different. So if you're using the term normally open and normally closed, you'll say to yourself, is there power flowing when the switch is in its normally off position or in position A? An open loop circuit is simply going to be not influenced or influenced, or not influenced or influenced. Open loop type or closed loop type. The bottom line is, what do you want to have happen when the door is closed? Do you want power to flow or do you not want power to flow? So this open loop circuit, when you take it out of the package, when you take this open loop circuit out of the package, you recall we have continuity. Okay. But when we influence it or close the door, we then break that continuity, or it goes to we have continuity, now we don't have continuity. So that open loop is when it's influenced. Oh, pardon me. It's that open loop is being influenced here. So that is opening the circuit. So the open loop in its natural state is going to be, it will not permit power to flow. A normal position for a door would be in the closed position. That's really the leap of, okay, who's to say that the normal position for a door is open? It might, I suppose it might be always open. Well, not really. I mean, even doors that are held open with electromags in corridors of hospitals, they're not meant to stay open permanently. Actually, in fact, they're meant to be closed and latched. That's their intent. That's the reason that they exist. So, at the end of the day, what do you want to have happen when the door is open? What do you want to have happen when the door is closed? If you don't recall open loop and closed loop, which I don't, I refer to product catalogs, cut sheets, technical data sheets, or a video of someone literally showing that there's continuity. So when the door is open, there's continuity. Okay, so there's going to be power that's going to flow. And you'll have to just determine, what do I want to have happen when the door is closed? What do I want to have happen when the door opens? And the switch type is going to, you will then know what switch type you need. If you want no power when the door is closed, then you want an open loop. When you want power when the door is open, then you want an open loop. If you want it reversed, you go to a closed loop. Yellow leads, these are priced and sold as each. This happens to be a bag of 10 that's here. Let's switch to the screen view and let's take a closer look at some of the supporting information. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, here are some images that we have of the hardware that we can take a look at. The packaging. It's a 189-12-BL for black. These are available in different finishes. I'll show that to you in a moment. This is probably going to be the jam portion, would be my guess. It's easier to get power to the header or to the jam than through the door. So let's consider this the frame portion. Let's call that, therefore, the door portion. You've got those snap tangs that are there. There is a product brochure as well. Let's take a look at that. Recessed magnetic contact. 12-inch, 22 gauge, American wire gauge, leads or terminal screws. Longer leads, zip cord or jacketed cable upon request. Built-in end-of-line resistors and diodes upon request. Supervisory loops upon request. Switches and magnets available separately. Colors: white, brown, gray, or black. That's nice. They've got 4 options. UL10C fire rated. Awesome. So we've got a 189-12. That tells us it's a 1-inch diameter, that it's open loop. Standard gap up to 1/2 inch on steel. Gaps will increase substantially for installations other than steel. So obviously the nature of steel itself is influencing the magnetic relationship between the two parts. And that's important to know because you're not going to have a change in state below 1/2 inch, which means you can get something open up to 1/2 inch before you'll have a change in state. So that's important. That may, I mean, think of a window that you can slide open 1/4 inch and not trigger the change in state of the contact or the door switch or the window switch. So that's really important. And there are GRI makes high security ones in the sense that that gap is far, far smaller. That's in their catalog. We won't touch on that here. So 1-inch diameter, open loop. We're doing a BL for black. Standard gap up to 1/2 inch. Okay. Now in the table on the second page, well, here's the table, but the dimensional properties are here for our 1-inch unit. Yeah, here. This would all apply. This is going to be the smaller 3/4 inch units. This is a 1-inch unit because they do have 3/4 inch diameter and 1-inch diameter. Now the table, we get right to our 189-12 loop type open. They would therefore call it normally closed. And when I asked AI if open loop and normally open were the same, it said no, it's not. It's not the same. This chart is nice because if you're looking at a switch and it's classified as normally open or normally closed, and you want it to have an open electrical profile, then normally closed is what you want. Read form, that's just a technical reference. Ohm value, watt value, maximum voltage value, and maximum switching current. That's important to know that you can only pump 250 milliamps through this switch. So you're not going to want to power electric latch retraction on an exit device through such a switch. I don't see how you would, but you couldn't do that. It can't handle the current. Other part numbers with their electrical profiles are here as well. So there is a link below this video as seen here to the manufacturer's page, and from here you can pull up not only all of the GRI products that we sell by means of this horizontal navigation here, but also a link to the manufacturer's website, as well as a link to the full product catalog. If you want to see, if you're in the door and hardware business, this catalog is overload. These folks, I'm about to say they don't cater to the door hardware industry, even though they do, because they make lots of products. But they cater to every industry that requires some sort of small piece part that is electrical in nature. Overhead door people, window people, alarm people, all kinds of stuff. Let's wrap up this video on camera. Now, in conclusion regarding GRI or George Risk Industries, I only wish that I had more opportunities to use their product, and I say that because, sure, it's a well-made product, and sure, it does the job very well, and sure, I can get my hands on it usually when I need it, and sure, it's a very economically it's a product that is well positioned in the market in terms of cost. The material's not super expensive, they're the manufacturer, it's not third-party labeled. But the real reason that I wish I did more work with them is every single time I've called them with a technical support question, whether it be, hey, help me understand normally open and open type, or, open loop, these folks just stop and take their time to help you understand it. Not just get the answer and you move on, but to help you understand the principle of what's happening. They're very patient, very caring people, and I've called them 3, 4, 5 times with technical questions, and they have always, I've never gotten voicemail, I've always spoken to a person. It's generally a lady, and everyone I've ever spoken to, especially that lady, are extremely knowledgeable, extremely expert on the subject matter, and it's for that reason mostly that I wish I could buy more of their product. I just need to, anyway, they earn their business, and I would consider them a single source, a primary source for this material. Any questions on the 189-12 or any other George Risk Industries product, please feel free to reach out to us. Thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.